The current challenges of today's motion capture technology can limit their practicality to specialized environments, motions, and types of performances. Rather than depending on high-speed cameras, our system is based on inexpensive, solid-state infrared light projectors. A structured series of patterns called gray code are projected into an area at 10,000 times a second to divide and label the space. The infrared projection is invisible to the human eye. Shown here is the space labeling pattern from one projector. For illustration, it is 1,000 times slower than actual speed and projected in a visible green light. Next, the pattern is received by passive tags which determine their own location in this labeled space. By exploiting the epipolar geometry of several well-positioned projectors, we are able to generate 2- or 3-dimensional tracking at 500 or 125 updates per second respectively. Here, we demonstrate that a tracked prop can recover its own position in a scene for later computer graphic compositing. The high-speed nature of this performance produces motion blur. However, we still obtain 125 samples per second. Our tags are capable of much more than only location tracking. They can also recover orientation data. This is determined by using the received intensity from the alternating flashes of 4 orientation beacons. Thus, you may have noticed the subtle rotation of the sword as it followed the actor's performance. Each tag comes equipped with an RGB sensor as well. This is the most novel of our incoming data. From it, we can record lighting conditions from the actual setting. Here, we use this information to alter the color of an actor's clothing to appear the same as he passes through different hues of light. This information could also yield the albedo of a sampled point and help the integration of synthetic elements in post-production. The accuracy of our tags can be seen here to be less than 1 millimeter. In this demonstration, the tag is transmitting its position in real time via Bluetooth connectivity rather than storing it for later. Our system has many additional advantages over current motion tracking solutions. First, it operates independently of controlled environmental lighting. Here, a basketball's motion is being tracked regardless of extreme variance in scene lighting conditions. Next, tags remain small enough to embed directly into theatrical wardrobe so that motion and lighting can be captured at the time of filming. When these factors combined, new possibilities and locations for motion capture evolve. Tracking motion on location is a highly sought after, yet technically elusive proposition. Our system now allows production teams to capture the motion of an actor at high speeds, on location, and using existing lighting conditions. The next advances for the system are already being realized. To begin, incredibly high-speed IRDA photo transmitters and receivers, common to television remotes, now allow us to operate at 20 kHz for over 6,000 samples of 3-dimensional data a second. In this demo, an IRDA tag has been attached to a fan blade. When it passes in front of several predetermined positions, its LED illuminates. As it spins, it passes in and out of these locations, creating visible dots. As the fan reaches its highest speed, these dots are clearly visible, indicating that the tag is still aware of its location, even at incredible speeds. Finally, our first-generation gray code projectors utilize 8-bit patterns to label space. Our next-generation system, seen here, uses 12-bit analog masks to increase the accuracy of tag tracking to 100 microns, about twice the width of a human hair.